And I want to figure out what is the force on charge Q here. What do I call this? Q sub P. So what are the force on Q sub P from the linear from the line? And let's look at the magnitudes now. Now when we are doing this, I can't make an assumption about this line. If I had spherical symmetry, I could assume we have a point charge in the middle, which is what we did last time. But this time, I can't make that assumption that it's just a line right here, because this is the closest point. The charge at this point is going to have a much bigger impact than one that's over here. So what I have to do when I'm faced with a charge distribution where I can't make that make some simplifying assumption is I have to basically pick a charge here, a small little segment of dq. And there's a force in that direction. It's supposed to be a straight line. Now I didn't specify the value of q, whether q was positive or negative, and that's fine. I will treat them both like they are positive. If one of them ends up being negative, the formula is not going to change. A negative will get introduced into the equation, and we can deal with it at the end. This angle right here, I will just label that as theta for right now, which would be the same angle as here. Now, you can go through the painstaking aspect of doing the problem twice, but we can make the symmetry argument that for every point on this side of the closest point, there's one over here which will have a force in that direction, and so all of the horizontal components will cancel out. So we really only have to do half the problem, because I know the only component that's going to survive is the vertical component.
So it makes like a cone?
Yes. Well, actually, it's a line, not a plane. So basically, it's a whole bunch of vectors within the plane here.
Oh, okay.
Isn't the vertical components all the same?
No, because the vertical component here, that's straight up, that's going to be the strongest, but the vertical component from here, it's a weaker force because it's farther away, and also the vertical component would be much smaller.
So where's the force coming in the middle?
Where's the what?
The force coming from?
The force is coming from
Oh,
this.
okay. Oh, that's okay.
So when you're dealing with a distribution, you take a small little chunk of it and you set up the equation assuming this is it. You get it in terms of a single variable and then integrate.
So it doesn't matter where you choose it, like.
No, it doesn't. Did you want a big difference about it?
No, cool there.
Let's also set up a coordinate system that will make this simpler. What I'm going to do is I'm going to set up, make that an x and y axis. So that's the ordinate right there. This way, this distance right here, because remember how powerful, how the magnitude of that force depends upon how close this is to the charge here. So this is going to affect it. So by setting my y-axis here, then x, that length is x, that length is x for one that's a similar spot over there. So this length here, let's say is x. That distance is r. I actually should not use little r there. I'm going to change that little r to big R. Sorry for the inconvenience, because I want that to be little r. Well, the force at Q at Q sub P because of dQ, we got Coulomb's law for that. K, K sub C, K sub E, Q sub P, dq over R squared. Now, that's just the magnitude of the force, but remember, we're only looking at the vertical forces here.
So I hat, no, I hat, J hat.
If you want to go with I hat to the right, J hat up, is that where you're going?
I guess the accursed,
And we only want the vertical component, so yes, J hat given that convention, but then sine of theta, J hat. Because it's only the vertical component that's going to survive.
huh.
If you wanted to do the full thing, there's bad notation over there, but hopefully you have the spirit of it. The force on QP, because of the line of charge, would be K sub C QP dq over R squared. Cosine theta I hat plus sine theta J hat. If you work through it, this term is going to drop out. This will be equal to 0. The bad notation I commented on was the fact that I know it's going to be in that direction. I have J hat, it will be in the J hat direction, but I've got magnitude symbol, I've got the absolute value symbol here. So technically, we've already thought through the direction.
Oh, okay.
If that's the magnitude, this should not have the vector on this side. That was just that notation. All right, let's see what our variables are. R is a variable, Q is a variable, and theta is a variable. We are left with the same situation as yesterday, where we've got 3 variables, and we want to get down in terms of 1.
Teach us a triple integral.
I think we probably can do it without the triple integral, but I like where you're thinking. You want me to do a triple integral at some point?
Yes.
Yes.
Okay, that sounds like a groundswell. I got a couple of thoughts on it. Yeah, why not? All right, won't be here, but we'll do it. All right.
Got the triple.
So, first off, sine theta. I got my triangle right there. I know that is big R, that's little r, and that is x, that is theta. In terms of the physical triangle here, what is sine of theta? Big R.
R, big R, little R.
Say it again?
Big R, little R.
I felt like a word was missing.
Big R over little R.
There we go, that's the
Oh,
word.
it's, yeah.
Okay, I assume you've written it down correctly, but, so sine theta is big R over little r, opposite over hypotenuse. And so we can make that substitution there. So this now becomes KCQP dq times big R over little r, and that's over R squared. I'm gonna pull the constants out front, so that's KCQP QP, big R, and then what we're left with now is dq over R cubed. Now dq, we need to get in terms of some length. Now you have R in terms of length. This little r, that deals with, that's a length. I need to somehow get this in terms of it. And this was when we bring in this bit right here. I can find dq in terms of a differential of a length. So from that equation there, I know that dq is equal to lambda dl. dl is just this differential along here. dl would just be the same as dx. Some differential in the length here is just on my x-axis. So that would be lambda dx. Plug it into here, so now I have the magnitude of the force is equal to kc qp r times, I got the lambda dx over r cubed. I still have 2 variables here, I have x and r. So I need to get them
in terms of a single unknown, what is the relationship between x and r?
Cosine?
Of theta?
Cosine is, yeah, if we do cosine though, we're bringing theta back into it. Trying to avoid that.
R.
Did you follow what you say?
I know, I said tangent.
Oh, yeah, trying to avoid, we don't want to bring the angle back into it.
Is it, I don't know.
Pythagorean theorem.
That's the one.
Okay.
Flashing back, I was taking general relativity in college because one of the other grad students really wanted to take it and he needed a couple other suckers to take it too. And I said, sure, I'll do it. Anyway, horrible course.
We get to do the
The whole course on general relativity.
Yeah, that course came back. My goal in the first test was to understand the questions. I did not succeed. Oh. But at one point, the teacher was looking at us, he had a very thick Polish accent, and he talked about the theorem of Pythagoras. And I'm going, Pythagoras? I don't know who Pythagoras is. And he looks at us, and we like looks on our faces, and he said, Pythagoras, you know, a squared plus b squared equals c squared.
Oh, Pythagoras.
I think he was sensing frustration. Anyway, so we use the Pythagorean theorem. I know that little r squared equals big R squared plus x squared. And so therefore, x squared is, actually, I want to get rid of r. So r is the square root of r squared plus x squared. And so this now becomes kc qp r lambda dx over the square root of big R squared plus x squared. Cube. Thank you. All that to the 3/2.
This looks familiar.
Pardon?
This looks familiar. Give us a problem like that?
It's quite possible. So, I now owe. Just one sloppy notation after another. Technically, that's the differential math. But now I can integrate. I have a single unknown here, so f is going to be kc qp r lambda integral of dx over r squared plus x squared to the 3/2. So the question becomes, how do you solve that?
Isn't that the first question on the master set?
Yep.
Or similar to it?
I use the common integral.
I just use that.
You sub.
Can you use sub this?
What would you set u equal to?
The denominator.
And so then you'll have the
Like
x.
inside the parentheses.
So r squared plus x squared?
U is the x squared, R is the A.
What would you say?
So U is the, wait, are you talking about substitution or?
Well, he said you could use u substitution, so I was asking you to use it for you.
I use the common integral, just looked at a table.
So there's the math approach and the physics approach. So the math approach, what you said, u substitution, you said what's in the parentheses?
Yes, but I
think it's trig
didn't realize it was
substitution.
two separate variables.
You do the math, but I think it's trig substitution.
Yeah, you would have to use trig substitution. If you just said u equal to r squared plus x squared, you'll end up with 2x. You'll still end up with an x that you can't get rid of easily. So it is trig substitution the math way. The physics way, Phil has done apparently. You look it up.
What do you recommend?
What's that?
Do you recommend to look it up?
What was that?
Do you recommend to look it up instead of doing it?
Yeah, yeah. The math people have already done the work for us. We don't need to do it again. Now, I gave the question that's on the master set was a test problem, like almost every master set problem is. And one student missed the idea of the fact that you just look, I gave the formula, the generic common integral table formula at the top of the first page. Did not see that or did not think about it and actually solved it correctly using trait substitution.
Wow.
Hey, more power to her.
That's awesome.
However, my thinking was that you would just look it up. That's the physics way. We will trust that the math people have not lied to us.
It's all work.
Yeah. So it's a matter of finding the. This one. Did this a completely different way? Oh, that's using trait substitution. That's why that's looking strange. I need to find it. So there we go. This is, so what I have is that the integral of the x over a squared plus x squared to the 3/2 equals x over a squared square root of a squared plus x squared. So if you looked it up, you would find that or some variation of it. There's some more generic forms of it which you can derive that. Limits of integration, we have to do that also. What are the limits of integration?
Would it not be the?
0 and r, no, 0 and x.
X is the variable here. What's the smallest value of x?
Well, it's in here.
0.
Not 0.
Negative infinity.
Negative infinity. And the largest?
Infinity.
If it were a finite line, then these would obviously not